The MEMS approach, which you're now familiar with, is perhaps the most prevalent methodology for describing predicted probabilities. However, in some situations, MEMS may prove inadequate. Suppose, for example, that based on a controlled cross-tabulation, you might think that education works differently for younger people than for older people. If we were to estimate and compare the effects of education among two groups of respondents, those, say, who are 26 years of age and those who are 65 years of age, what would the comparison reveal? That's where the MERS approach comes in, marginal effects at representative values. Here once again is the logistic regression equation that SPSS estimated for the relationship between voting, the probability of voting, the logged odds of voting, and two variables, education and age. We already reviewed how to retrieve predicted probabilities. Let's now compute two sets of predicted probabilities. One in which we set age equal to 26, we'll call that pre_age 26, or just pre-26. And we'll also retrieve another probability setting age at 65. Let's go up here to good old compute. You might notice from the last module we still have pre-educ in here. All we have to do is modify this expression for the first predicted probability. Let's change the name to pre-26. This is going to be the effective education among 26-year-olds. I'll go over here and simply multiply the age coefficient times 26. That's in the numerator. Don't make the mistake of forgetting to do it in the denominator. I have done that on occasion. Type and label. We'll change this to predicted probability education voted 08, and then we'll change the name to age 26. That'll be our first set of predicted probabilities. Looks fine. We'll run that. Go back in. Go back to transform compute. Now we'll just change the age designation to 65. It'll be pre-65. I'll come over here, change this to 65 in the numerator, and this to 65 in the denominator, not forgetting to simply tweak the label of the variable to age 65. Continue and OK. Now let's have an interesting comparison here. Let's do analyze, compare means. The previous run from the last module is still in there. I'm going to click pre-educ back. We'll put pre-26 in. That's a predicted probability, the effect of education on the probability of voting for 26-year-olds. And we'll put pre-65 in. Everything else is the same. Hit OK. And we've got a lot of numbers in here, folks. What I'm going to do is delete that. Let's make it even leaner than that. Let's go to options and take out number of cases so we get a nice clean table. There we go. Consider the dramatically different effects of education for these two age groups. The patterns of marginal effects are quite different. For younger people with low levels of education, between say 0 and 10 years of schooling, notice that the probability is extraordinarily low, probability of voting, in the range of 0.03 to 0.31 we can see here. The educational increment with the largest marginal effect, that is the instantaneous effect, occurs between 12 and 13 years of schooling. Compare the probability profile of younger respondents, the sort of sluggish marginal effect in the lower range of education and a higher switchover or instantaneous threshold, with the probability for older respondents. Does education work the same way as read down the column of pre-65? Not at all. Here the probabilities start at a higher level at about 0.14 and build very rapidly in increments of 0.04 and 0.05, crossing the 0.50 threshold at between 6 and 7 years of schooling. Let's graph this. There's a wrinkle in the graph protocol now. We go to Legacy Dialogues, line. You're going to want multiple lines. You're going to want a line for the pre 26 probabilities and a line for the pre-65 probabilities. Here's the difference. Click the radio button next to summaries of separate variables. This will give us what we want. Go to define. We'll pick up educ, and then we'll go down and pick up our pre-26 and pre-65. There's the basic graph. Look at how different these logistic regression curves up here. And here's a challenge. Get into the editor and sort of discover some new editing skills. You can get a real nice looking graphic of this that plainly shows the very different probability profile of young people. The crossover is way up here, and the older generation with the crossover way down here.